Hi everyone, welcome back to Mind Over Math. In this video we're going to be covering the introduction to logarithms. That a logarithm and exponentials, which we've just studied, are inverses of each other. Well, you go, I'm not sure what an inverse is. Well, an inverse is the inverse of add is subtract. The a plus negative a, 5 plus negative 5 equals 0. You reverse what you started with. Multiplication, the inverse of multiplication is division. So we say c times 1 over c equals 1. This is called the inverse property. The inverse of squaring is square rooting. Guess what the inverse of exponentials are? Logarithms. Exactly. So let's look at the definition of a logarithm. A log is written with a small base b of a equals something, and by definition the b has to be larger than 0. It can't be a negative base, and b stands for base in that little subscript down there. But it can be greater than 0. It can be a decimal, it can be a fraction, it can be anything but 1. It could be 1.9. A, on the other hand, A is just like it. It can be greater than 0. It can be 1. It can be a decimal. It can be a fraction. So, if A is 0, and you look this up on a calculator, you would get an error message. The calculator would say error. That's good. You may not remember that, but at least it will tell you you didn't do anything wrong. You just found that it's not possible to do. Now, there actually are answers to some negative logarithms. There are calculators that do that. There's no scientific calculator that does that type of problem, but the graphing calculators do. So if you looked up the natural log of -1, you would find it is pi I. There is an answer, but it's called an imaginary number. So let me show you this. Find the inverse. So if I do the steps of the inverse, y equals log base b. When you do the inverse, you take the x and the y and you switch them. So I've done that here. I've switched the x and the y. The base b stays right there. I rewrite this logarithm as y equals b to the x power. Now remember, when you find an inverse, this y is not the same as this y. This is the inverse. So you put a little -1 up there. Now that doesn't mean -1 exponent, it means inverse. You have also maybe seen this written as f to the -1 power. And that's what this would show. F stands for a function. Okay, so why do we need logs? Well, let's say I have 10 to the x power equals 129. That's a statement. We're going to have to find x. So I actually know what 10 to the second is. That's 100. And I also know what 10 to the third is. That's 1,000. Now you'll notice here that 129 is at least between 100 and 1,000. It's really, really close to 100 compared to 1,000. So I couldn't find this answer apart from logarithms. This is why logarithms are used. So I can rewrite this statement, log base 10 of 129 equals x. If you notice here, the x is exponent, the variable x on the 10 to the base 10 of x. And I now can find, with a calculator, log base 10 of 129 is 2.1106. And what's that mean? Well, let's go back to the original problem here. That means that 10 to the answer, 2.1106, equals 129. Now that's really close. I had to round this off. That's what that means. Now this is crazy. Here's what 10 to the second 0.1106 looks like. It's 10 to the first power times 10 to the first power, which is 10 to the second, times 10 to the 0.1106. If you do this on a calculator, 10 times 10 times 10 to the 0.1106, you'll get very close to 129. You see, typically, we have an exponent, base E, base B, with an exponent on it, and x usually is up here in the exponent, and that equals some value. I just did 10 squared. 10 squared is 100. The base in the logarithm version of it is subscript down here. Look where the exponent goes. The exponent goes from up on the platform, the superscript, down here across the equal sign. So logarithms are actually finding the exponent. That's what they're finding, a missing exponent. See, we're used to having x in different places, and now with exponents and logarithms, we're going to have x being the exponent. This is also called, this value right here is called the antilog. That's another name for it. So let's take 10 squared equals 100. And I have a little story to tell you. 10 squared was walking out in the forest with 100. And a log fell on 10 and pounded him into the ground. 2 ran over and told 100 what had happened, and 100 came to see what was going on. So if you can remember this little illustration, log base 10 of 100 equals 2 was or did look like 10 squared equals 100. That'll help you keep the movement of the numbers a little clearer. Let me show you this one more time. 2 to the 5th equals 32. Write this as a logarithm. Now this is a true statement. It's not intended for you to solve. It is true. So what's this mean? This actually means 2 times 2 times 2 times 2 times 2, 5 times is 32. You know what 2 to the 5th means. It doesn't mean 2 times 5. So if I want to write this as a logarithm, I would write log base 2, that's what this is called, base 2, there it is, log base 2 of 32 is 5. 5 is the exponent. These are the very same statement, the very same statement. They mean the same thing. The entire purpose of logarithms is x is going to be here where the 5 is, or x is going to be here where the 32 is, or x is going to be here where the 2 is, and we're going to learn to solve those. In the upper right-hand corner, make sure you subscribe. In the upper left-hand corner, make sure you check out other videos. Likes are below, and make comments on topics you need.